So this page is what?
Going to
This fluent, you dragged fluent, right?
yeah.
Only fluent.
Only fluent. Oh, here's the mesh. Okay, let's try to desktop and here and here. Okay, wait a minute.
How was the seminar?
No, I don't go to seminar.
Oh no?
Yeah, no.
Okay.
No.
Cool. How about what do you think?
For me, I already attended enough, but I have to go to all because I want high mark.
Okay.
Because we have to fight for the scholarship.
Yeah, that's fair.
Okay, now your measure is important and display. I don't want to see this. I don't want to see this and this one and this one. So I display my okay and go. Okay, now is your the whole length of your XYZ. Okay, you can see now I changed to MS too bigger than what I said. Okay, it's only 1353 and I find okay this one is X and I find S.
So now we onboarded the surface mesh only, right? Not the
Yeah, we
not
all
the flow domain.
no, we are all done. So now I'm just telling you how to set in the Fluent. Okay.
But when we're saying the X minimum, X, Y, and Z,
You can
minimum,
see
maximum, Z.
millimeter is too big. Okay, so you have to scouting. Now too big. Okay, this one plus this one is okay. Okay, now is this number, but your actually your model only have 1353 point this one, right? So I have to rescouting. Okay.
So you multiply the X minimum times the X maximum to get
Oh no,
no.
XYZ. You have to minimize.
Okay.
Okay.
But you got I'm sorry. You got the number you got on the calculator. How did you get that?
Which one?
The number that you had on the calculator?
This
that
one and this one. Okay. Your
Right.
x length, the whole x length is this one plus this one, right?
Oh, okay. You add those two. All right.
Yeah, and you can find your whole x length is 1353. Okay.
And is that for the enclosure? The enclosure length? What is this we're looking at right now?
Oh, this one.
Yeah.
This one is your model. That's how I do.
Oh, okay.
Yeah.
So that's the full length of the model.
Yeah,
from
yeah,
the
yeah.
front to back. Okay.
The flu flyer.
Yeah. Okay.
Okay, so I have to rescouting. Okay. Okay, skip. Now we can find. Okay, now it's okay. You can find now
Did
the
it?
number 415.32 plus 938.343 is okay.
Why you didn't use the minus?
1,300. Okay.
That's the number. Okay, so
Wait. So for the minus.
Why you didn't use the minus actually?
minus.
Yeah.
Oh, because your point is here, and this direction is positive, and this direction is negative.
Okay.
Get it?
Yeah.
Okay, and you can see the axis top is this direction is the positive. X direction this way is positive. Y direction this way is positive. You can see in here.
Okay. But if your point is at the front, there shouldn't be anything negative because it's already at the front of the model.
No,
No.
this one because your point is here. Your point is here.
Oh, okay, yeah. So your
Yeah.
point is part way down the model.
Yeah.
Sounds good.
Okay.
That makes sense.
So close. Okay, and then choose your solver type. Pressure based because you're not in a uh, okay. Density base is only used in up to Mark 2 to higher. Okay, Mark 2 to higher, you have to use density base, and lower than Mark 2, okay, pressure base is okay, and velocity formulation is absolute, okay, and type because we are not going to use transient, we are usually use the steady, so okay, steady. Gravity in this simulation is not very important, so I won't click this one. But if you want, okay, click this one and you can find your ZX. Your gravity is down, right? On Z axis, and up is positive, so you have to set minus 941.
Oh yeah.
Yeah. Okay.
Yeah.
Okay. So I'm not using because in this simulation, gravity is not very important. Okay, then everything set is okay. Click check. Okay. You can find there's a warning says match check fail. It's normal because we are using the polyhedral or polyhexacore. Okay, it's normal. Normal. They will shows the match check fail. Okay.
Okay.
Okay, now we go into the models because we are all checked. Okay, multi-phase, no, we are not multi-phase. Okay, energy on. Okay, and then viscous. Okay, we choose the k omega and SST. But if your flow is very slow, you can only use k epsilon. But I'm usually use the k omega. Okay, there, click. Okay. Here don't need to. Okay, and okay, this don't need to because we are not heat exchanger or radiation or we're not using this. Okay, material because you say you are using water, right? Water
I want
tunnels.
to use that water channel for experimental.
Yeah.
But here I want to use the air.
Oh, okay. So we don't need to change this. Okay, air. We have to click here. Okay, fluid. Okay, if your density is constant, that means you are incompressible flow. But if you using ideal gas, this means
Compressible.
yeah, compressible. And if you are in the high Mach number, you have to. Okay, your viscosity you have to
But we
change
have
to 1000.
But you have to calculate the speed from the Renan number equation, right? That we choose our growth of boundary layer. That we choose it based on Renan number.
Yeah.
So we have to take the values, and from there we have to find the velocity. So the velocity we choose 10 meter per second, right?
10 meters per second.
So we have to here also follow the same speed, right? Or it's different?
Different. I think it's different. Let's choose the Reynolds number. Okay. I think it automatically shows in because we are not changing the Reynolds number because it will automatically to use the Reynolds number. You see, because you are 10 meters per second. Okay, it will change yours. Yeah.
Okay, but so the model. So this electronic model is based on your.
Oh, this is
model
not. It's not electronic. It's
the 3D model.
yeah.
Right. It is based on the actual model you have downstairs, right? It's based
small
on
one, yeah.
the small one. So
Yeah,
the
it's very
size is that. But if you're using the other one in water, and you're trying this one in air, then
Oh, it's
then
Reynolds
it's not
number.
gonna be
Yeah.
Yeah, that's
So
why I'm
if
not
you
talking about the Renan number for water. I'm talking
Okay,
about
you're-
the number that we use for the.
Okay, if
setting up the
if
mesh.
your model is still this size and you are using the air,
Yeah.
your speed or something will be changed, or if the total pressure or something you have to change. Yeah.
Since he's doing some tests in the water, would it make sense to also try tests in the water here? Because then
Okay,
you could
if you
use
want
the
to-
same velocity, same everything as your test. Or does it make more sense to just say have the measurements be the full size measurements?
No, because you say this model is using in water tunnel, right?
Yeah.
So the Reynolds number will be different. So if you want to catch the same data or something, okay, maybe you have to bigger your model, or still using this size, but you have to, your velocity, because in air you have to change or something you have to change it. Okay, it's based on what you want. Okay, if you say you still want to use the water, right? So you can here fluid, and here's a create edit, and you can type the name water and choose okay, chemical, okay, fluid data, and then choose the water liquid. Okay, everything constant, okay, and then copy, close, and then change, create, delete. Oh shit. Okay, sorry, copy, close, change, create, close. Okay, you have the water. So here is your cell zone. Click here, and then you can choose your things into water. Okay, so now you're using water now.
Okay, so you have to change it in two places.
Yeah.
Both materials and cell zone. Okay.
My material is to add water, and here's your home mesh, the inner, right? You have to calculate. Okay, so we choose the water to become our, calculation in the whole domain we are using water. Okay, so it's up to you. You can use air or use water. It's up to you. But if you want to change some quantity, okay, maybe today I want to do compressible flow. Okay, I choose to ideal gas, and here viscous I change to Sutherland. Okay, and click.
But why we choose idle flow? Why we want the flow to be compressible if we are using that?
No, if you are compressible, the name is ideal gas. If you want to use incompressible, okay, it's constant density.
Yeah.
Okay.
But for us, we're going to do the flow on low speed, right? So
If you are using
if
low
we're doing
speed,
low speed, so I make it constant.
yeah.
Okay.
If you are very low, you just use constant, and
Because I'm
Okay,
working on low
and
speed aerodynamics.
the
not,
and viscous just use constant. Don't need to use the substance law. But if you want to use water, okay, yes, okay. Okay, so we are going to boundary conditions. Okay, because we are outer base. Okay, we have 6 phase, right? Inlet, outlet, and top, down, right, left, right. Okay, because top and down and left and right don't have anything, right? So if we are in the supersonic, the top, down, and left and right we can set to pressure far field. But no, sorry. Sorry. Okay, pressure far field is only used in compressible flow. If we are in compressible flow, we are just use the wall, but we can can change the number into this. Okay, this wall is free slip wall. Okay. Now, okay, for our button, okay, click two times, Okay, we can find the method is wall, and then here specify shear. All of it is 0. That means free slip.
Mm.
Okay.
All right. So there's no zero slip condition.
Yeah, it's
Okay.
wall. There's no friction.
Okay. Cool.
So, okay, okay. This situation only used in incompressible flow. But if you are compressible flow, you are using the things called pressure far field. Okay, right click and this type and here pressure far field. Yeah, it's using compressible flow. Okay, inlet, change the type into velocity inlet. Okay, here gauge pressure to 0 because you're okay. Later I will show you. Okay, velocity is set to 10 meter per second. Okay, click OK. While saying your gauge pressure is 0. Okay. Oh, sorry. There's something I didn't. Okay, still zone condition. And here is the option condition. Okay, you can see operation pressure is this one. So your gauge, if you are only in, okay, if you set your gauge pressure to 1 Pascal, that means your whole pressure is 101326. If you set to 0, okay, it's only 1 ATM. Okay. Yeah. Gauge pressure you on. Oh, okay.
Engagement. Yeah. Cool.
Okay, so okay, because we are subsonic, right? So this point we have to, okay, the reference pressure location we have to the point have to close to the outlet. Okay, we go back to general. Okay, scale. We can find our this one is our outlet, the plan outlet, right? So we have to change this number to 938, just close to the outlet domain, but not the outlet domain.
Oh, so beyond or before the outlet domain?
Before.
Okay.
Your outlet domain is here, so you have to before.
A little
just
bit more, okay.
a little bit.
All right.
Okay, so click OK. Okay, and close. Okay, so our now inlet is okay, and okay, this one. Oh, sorry. This one is your aircraft. Yeah, left side. Okay, so this left is your. Okay, I also change to.
So all of them have to change to spherical stress. All of them have to change to spherical stress.
This one, right?
Yeah.
Left, because it is your you know what I say.
I mean, like once we open all the flow domain sites, we have to choose this, right?
Yeah. But your aircraft don't choose that.
Yeah, for aircraft, I didn't touch anything.
Yeah. Okay. Okay, so outlet. Sorry. Outlet. Right click. Type. Okay. Pressure outlet. Okay, gauge pressure is set to 0. Okay, and then okay, this one is your aircraft. Okay, right. This one. Okay, top. This one. Okay. We all setting down the mesh in our condition, and this one don't need to check because we are not dynamic mesh or this. Okay, so we are going to solution, so check method. Okay, pressure second order, momentum second order, just change to second order. Okay, this one we have to. Sorry, okay. This one don't need to check. This one don't need to check. Just
What's that?
don't need to check. Choose the
Pseudo.
pseudo transient. This one I just heard from say wait. Let's say it will in some cases it will cause the conversions very slow.
Oh.
Yeah, so not in some cases they my friends just says every case he just choose this one and causing the convergence very slow, so don't need to choose this one. And this one high order term relaxation, this one only choose if your convergence is very hard, you choose this one.
Oh, so if it fails to converge a few times,
Then
then maybe you choose
not
that?
fail. If your convergence is very hard to converge,
Oh yeah.
you choose that.
Okay.
But if your convergence, okay, not very hard to
Then
yeah, so
skip it. Okay.
okay. Okay, so okay, we are down this one. Okay, go to control. Okay, flow current number. Let's say just use 5 for in case. In case this flow current number set to 5 is the most safety number for most case, but sometimes your case, if you have some problem in your case, maybe you have to change your current number. It's also based on case.
Okay.
Yeah, case by case. Yeah, but mostly we just set to 5. Yeah, mostly. If you if one day you find, okay, I set to 5 and it's still some problem, maybe you can change your current number. Maybe very hard to converge, or okay, it's diverge or something, then you can choose you can change the current number.
Okay.
Okay, so sorry, I just check again. Okay, so we are down here and then going to residual. Okay, residual we just set to okay, where you want to converge. Okay, for steady state we always set to 1 minus 6, so
How many zeros are there? 3 more?
yeah, 3 more, because in steady state we have to use 1 minus 6.
Okay.
Yeah, steady state, only in steady state.
So this is the level of accuracy that we're requiring.
Yeah.
Okay.
Okay. You choose okay. Okay, minus 6. Okay. So now I'm going to run calculation, and this is the number of iteration you want, maybe 500 or something. Okay. Oh, sorry. 前进. Okay, I forgot to initialization. Okay, here and hybrid. Hey, 等我一下. Okay, hybrid initialization. Just use this one. Okay, and then choose initialize. Okay, wait for initialize.
So basically, when I'm trying to do the fluent, I'll just import the mesh for the surface.
No, not for surface. It's your whole mesh.
With the flow domain.
Yeah.
With the boundary layer growth, the one we did last time.
Yeah.
Including that.
Yeah,
But I
including
don't see
that.
it here. Like why?
because
you
I
hide it.
because I only chose this one.
Okay.
Yeah. Yeah. Okay. So everything initialized down. Okay. So we go to run calculation and set to 500 and then calculate and it run.
And then it
And
runs.
then wait for the solution.
Okay.
Yep.
And it runs for hours.
Yeah, no, not exactly.
Oh, okay.
I'm just use 10 minutes to finish this.
Oh, alright.
Yes.
Okay.